Hello everybody, my name is Veronika Kollmeier and I'm a doctoral candidate at the Institute of Road, Railway and Airfield Construction of Professor Freudenstein at the Technical University of Munich. The main focus of our institute is the experimental and theoretical research on strain and stress in the superstructure of roads, railways and airfield infrastructure, as well as the design and development of new pavement systems. My research focuses on resilient materials in the construction industry. In the framework of this presentation, I want to discuss the development and use of tests on under-tie pads in regards to the European standard.
This is a short summary of the topics I will be discussing. First, I want to give a short overview of why under-tie pads are even relevant for the track system, its requirements and benefits. Then I will come to the development of the testing of under-tie pads in Europe in the last 30 years. Finally, I will discuss the insights and problems that have arisen during and after this process. To define requirements for any component in the ballast track system, it is important to know the requirements for the whole system itself. So a variable settlement behavior is the basic for stability and safety of the system. It also leads to a minimization of maintenance, which always goes hand in hand with cost reduction. Due to the ever-increasing population density, the importance of noise-reducing characteristics is growing more and more. With this in mind, the main requirements for under-tie pads are high resistance to contact pressure of the ballast and therefore a long lifetime. Elastic tie pads improve load distribution and fix the ballast grains in their position. So a long-lasting elasticity is essential for the effect of the under-tie pad. The dynamic behavior must meet the special requirements of the respective project. At last, the under-tie pad must not interfere with conventional track maintenance. Together with an easy installation, the cost should be kept as low as possible. Now I come to the benefits that come with the use of under-tie pads. Due to the increased contact area, a higher protection and a lower abrasion of the ballast is achieved. The difference in contact area is clearly visible in the pictures between the unpadded tie on the left and the padded tie on the right. By reducing the vibration amplitude under the tie, a higher sound and vibration protection is possible. Under-tie pads reduce the rearrangement of the ballast as well as the settlement, which also leads to a better tracked position, which again results in improved ride quality and comfort. This diagram shows the variety of the deflection under load that can be achieved by using different kinds of under-tie pads. The green line shows the deflection of an unpadded tie. The yellow one of a hard under-tie pad and the blue one of a soft under-tie pad. All this leads us to the question how we can describe all necessary characteristics of under-tie pads realistically and reproducibly. The first track equipped with under-tie pads was built in 1990 in Norway. It was followed by test tracks in Denmark, Germany, and Austria. In 2000, the testing of under-tie pads was first mentioned in the DIN 45673 Part 1 about elastic elements of the superstructure, but with a very limited amount of different tests. In 2004, the first specification of under-tie pads was released by the Deutsche Bahn, including applicable limit values. These were developed by the Deutsche Bahn and the Technical University of Munich, based on first experiences on track and lab tests. 6 years later, Part 6 of the European Standard 45673 was released, which defines testing methods for under-tie pads. 2016, the European Standard for concrete ties and bearers with under-tie pads was published. This standard replaces the DIN now. The DBS is still valid because it is not a standard, but a specification. As you can see, the current standard already had a development over a long time. From 12 pages in the DBS with testing methods and applicable limit values to only testing methods in 20 pages in the DIN and over 80 pages in the European Standard. We are performing a great variety of under-tie pad tests in Munich, but today I will only have time to pick out some selected topics regarding the testing of under-tie pads and its development over time. One of the biggest developments was the process to determine the bedding modulus of the pad. At first, the measurements were made in a ballast box. The bedding modulus of the ballast was determined with unpadded ties. For padded ties, the bedding modulus of the pad was determined in conjunction with that of the ballast. Subsequently, the bedding modulus of the pad in the ballast bed can be determined by the difference of the measured values. As you can see, it was related to a labor-intense test setup and difficult logistics. So the aim was to create a load plate which imitates ballast and can be used on smaller samples. All load plates that were developed over the time are the attempt to simulate the contact surface of the ballast. The ballast plate, according to DIN 45673, was created as a steel cast of ballast stone impressions on the formation protective layer in 1990. The ballast plate can clearly not reproduce the real conditions in the track, since in reality, the ballast stones under the tie are more sharp-edged. In order to approach the real conditions prevailing in the ballast bed, the tomb plate was also developed at our institute. This consists of real ballast stones bonded together. It was more meant to be used in fatigue tests and not for the determination of characteristic values. Measurements on these are characterized by strong scattering, which is caused by their asymmetrical surface if the test specimen is not installed exactly centered. To overcome this problem, a new geometric ballast plate with symmetrical profiling was developed, which also has a reducible and describable geometry. and has not to be molded like the ballast plate according to Dean. Here are two examples of testing the bedding modulus with different load plates. The ballast plate according to Dean on the left side and the geometric ballast plate on the right side. This diagram shows the comparison of the simulation of the ballast superstructure for the determination of the characteristic values. It shows the stress deformation curves of the 4 different plates, using the example of a soft pad with protective fleece. The highest stiffness, corresponding to the smallest specimen deflection, was achieved between flat slabs, since here the entire surface of the pad counteracts the load. The bedding moduli determined on the geometric ballast plate and the ballast plate according to Dean are roughly comparable. When testing with the tomb plate, only a small part of the pad surface is stressed, since only the tips of the ballast stones come in contact with the pad. As a result, the largest deflection is measured here, corresponding to the lowest stiffness of all the test methods considered. The geometric ballast plate is the load plate in the latest standard. Now, I will point out some current testing methods. In contrast to the Dean, the EN includes testing on whole ties. For example, the pull-out test. It is used for the determination of the homogeneity of the bond. New is also the additional fatigue test with the geometric ballast plate. Before, the fatigue test was performed on ballast. This test evaluates the durability of the undertie pad in contact with the ballast. This fatigue test permits the evaluation of the interaction of the ballast with the pad. With the geometric ballast plate, a fatigue test, because of its homogeneous and reproducible loading, evaluates the durability and stability of the bedding modulus and vibration characteristics of the pad. This test permits the evaluation of the long-term variation of the bedding modulus. These pictures show the test specimen after the respective fatigue test. On the left, after the ballast box, conclusion about the wear and abrasion with undefined contact surface can be made. On the right, after the fatigue test with the geometric ballast plate, findings about the variation of stiffness with a defined contact surface can be made. The undertie pad can also be tested alone. The static and low-frequency dynamic modulus of the undertie pad, determined alone with the geometric ballast plate, allows quantification of the vertical modulus of the pad without being influenced by a bond system with the concrete. It is only used for the quality assurance during the production of the undertie pad. Here you can see the test setup with only the undertie pad without a concrete block. Even with tests that are defined by a standard bring some difficulties with it. In this case, the evenness of concrete blocks often influences the testing and its results more essential than the product itself. In contrast to the Dean, the test for the shear strength was removed from the European standard. However, This test provided essential knowledge about the detachability of the tie pad and thus the recyclability of the entire tie. VEN does not provide any limit values. The justification for this was that the requirements should be left to the railway companies for specific boundary conditions. But there are also additional documents, for example, the IRS 70713 Part 1 of the UIC, in which recommendations are given. Despite development over the last 21 years, a useful standard always needs progress and development. Some difficulties only occur by its practical use. To ensure fair competition, the testing of standards should be applied to as many regions as possible. So maybe the lessons learned with under-tie pads and under-tie pads test standards in Europe can provide useful knowledge to track and standards engineers working with under-tie pads worldwide. I would like to close my presentation with a quote from Benjamin Franklin. Without continual growth and progress, such words as improvement, achievement, and success have no meaning.
In the end, I want to thank you for your time to watch my presentation. And if you have any questions or need for discussion, please contact me.